Okay, so our next lesson is learning about oxidation numbers. And oxidation numbers can be very helpful when taking a look at what's happening with the reaction, knowing what's being oxidized, knowing what's being reduced, and can help with balancing in future lessons. So first, what they do, just kind of what was mentioned, it also keeps track of electrons, the amount of electrons being transferred. Everything that you see within the reaction, every atom, ion, or compound, we can assign an oxidation number to. They are positive and negative integers. And lastly, there are some rules that we're going to memorize, and that allows us to assign these numbers. So the first one is elements by themselves have an oxidation number of 0. So like O2, this oxygen would have an oxidation number of 0. If you have like sodium by itself, like sodium solid, this would also have an oxidation number of 0. So anything that's alone as a gas or in its natural state has an oxidation number of 0. Simple ions have the oxidation number of the charge. So like silver positive has an oxidation number of positive 1, chlorine negative has a negative 1, and copper positive 2 has an oxidation number of positive 2. So within the compound, if it's a simple ion compound, or like this one, an ionic compound coming together, the sodium within this compound has an oxidation number of positive 1, and the chlorine has a negative 1. If it is a compound, then you want your oxidation numbers to add to 0. So positive 1, negative 1 would equal 0. This helps us when our compounds get more complicated. So now there is rule number 3, where oxygen is always -2 as an oxidation number, except if it's a peroxide. So within this example, we would assign oxygen as -2, and then hydrogen would be +1. So this would be another rule in a moment, but just even figuring that out, if we know oxygen has to be -2, then the whole water molecule has to add to 0. So if there's 2 hydrogens, they would have to split a +2 charge, giving it +1. Coming over here, oxygen is going to be -2. Magnesium is a simple compound or ion, so +2. And now again, the whole thing has to add to 0. So just adding this up, oxygen, there's 4 of them, so that would be a total charge of -8. And then magnesium is +2, so the sulfur here would have to be +6 so that our whole compound can add to 0. Now, these are the 2 peroxides you would see most often, hydrogen peroxide and then this one, and Na2O2. So because it's a peroxide, now oxygen is -1. So these are the ones you want to look out for. Other than that, it's just -2. So then we could just figure the rest out. So if oxygen's -1, hydrogen would have to be +1. Over here, if oxygen was -2, sodium would have to be +2. Now the next rule is hydrogen is +1, except directly bonded to a metal, then it's -1. So within the water compound, we've already seen up here how hydrogen's +1. Down here, you are directly bonded to a metal, so it would be -1, and lithium would be +1. Again, directly bonded to a metal, so -1, and then there's 2 of them, so barium would have to be +2. Now, those are our rules, and once we use our rules, that would be your fixed numbers. So like oxygen being -2, hydrogen being +1, other than our exceptions, and then our simple ions. Then rule number 2, we've been using already. The sum has to equal 0 if it's a neutral molecule. If you do have something that's polyatomic in terms of an ion, then you want the sum of all the numbers to equal the whole charge. So let's take a look at a couple examples. So this first one, SbCl5. So what I would start with for SbCl5 is knowing that chlorine has a -1 charge. I would consider that one the simple ion. And then there's 5 of them. So Sb would have to have an oxidation number of +5, so the whole thing can add to 0. The next example, K2Cr2O7. Oxygen is going to be -2. Potassium here would be +1, and then you would want this whole thing to add to 0. So -2 times 7 is -14. Over here, +1 times 2 is +2. And then for chromium, we know that all together we need it to equal +12, and I'm getting that because I want all of these together to equal 0. But then there are 2 atoms, so this +12 needs to be split by 2, so chromium in this compound would be +6. This last one, HiO3, again, oxygen is always -2 unless with a peroxide, hydrogen +1, so we'd sign those first, and then taking a look at our total, we would know that all together, from the oxygen, we're getting -6. Then we have +1, and to add to 0, we would have to have our I be +5. Now, if you have an ionic compound, so you want your whole thing to add to the charge. So if I take a look at NO3 negative, again, oxygen is going to be -2. So that would be a total of -6. So to get this -1 charge, nitrogen would have to be +5. Our next polyatomic is CrO4 -2. We assign our fixed number for oxygen, and then chromium would want to be +6, so that if we added our total, so +6 from chromium, -2 times 4 is -8, would give us our ion charge of -2. And then that last one, PO4 3 negative, fixed number, -2. -2 times 4 is -8. If I need my whole thing to add to -3, my phosphorus has to be +5. So that's what we're going to start with. It says, what is the point? If you now can assign your oxidation numbers, you know what's being oxidized and what's being reduced. In terms of the numbers, if you're becoming more positive, you can take that as your atom or ion is losing electrons, so that's oxidation. And if you're becoming more negative, you can consider that a gain of electrons, which is reduction, which lets us see which reactant is undergoing oxidation or reduction. So I hope that's helpful in assigning oxidation numbers. In the next lesson, we will build on that and start to balance reactions. Thank you for watching. I hope this helped.